Right. Okay. So let's go to, yeah. All right. So now today we'll see how we can basically apply these formulas that we learned yesterday for parallel, where we learned that total capacitance is when we add the capacitors, and in series we got to add them by taking the reciprocals, and at the end we have to take the reciprocal again. So now let's have a look. So the first combination that we're going to see is very simple one. To start from very basic, you guys have no issues. So question one. In question one, you got one capacitance as 60 microfarad and one capacitance as 30 microfarad. So I'm going to basically teach you the way to solve all these problems, and obviously they're basically very simple. You won't have any issues. They're just like, circuits that you've done before in AS. And the total voltage that is given is this. Okay. So in this question, the first part, it says, what is the net capacitance? Net means total, by the way. Then in part B, they've asked, what is the net charge? In part C, they say, what is the total energy? Oh my God, please hold on a moment. Hello. तुम्हारा आया नहीं बेटा? Okay. All right. So what is the total energy stored? And part D would be, what is the total voltage across each capacitor? And finally, in part E, they want us to find what is the energy stored in each capacitor. All right. Now, for the first one, if you see, this is a series circuit. Okay. And when you have a series circuit, we know that the formula that we're going to use is 1 upon C total equals to 1 upon C1 plus 1 upon C2, which we can write it as 1 upon 60 plus 1 upon 30. Now, when you solve this in your calculator, just don't forget that when you're basically writing this like this, let me just show you. Wait a second. You write 1 upon 60 plus 1 upon 30. You get an answer. You then take a reciprocal again, because this is also reciprocal. So the C total is going to be 20 microfarad. Let's call this C net because they want us to call it net. All right, is it clear, everyone? Okay.
Yes.
Now, if you go to the next, they say what is the net charge? So it's very simple. You just need to use the capacitance equation, which is Q equals to CV. Now for Q equals to CV, the total capacitance was 20 microfarad and the total voltage that is available to us is 12. So I'm just multiplied by 12. So it's going to give us 240 microcoulombs. If you feel any difficulty while I'm doing this, please let me know. Okay. All right, everyone. Any questions there? Yes, Abu Bakr, where have you been? Abu Bakr, don't tell me you were sleeping and I had to wake you up. Okay, now, okay, all right. Now, then it says, what is the total energy stored? Now, we already know the formula for energy because you see, we have charge, we have capacitance, we have voltage, so we can use any formula that you want. But for now, let's use half times Q times V because we know we want total, so we want to basically multiply the total charge and the total voltage available to us, and when we do that, it's going to give us 40 and 40 microjoules like that. Now you might be wondering why I'm not changing micro at any point, because this is just to make sure that you guys have enough practice, because in the real exam they will also give you the same. They will ask you answers in microfarad and microcoulomb, microjoules. So you just need to just practice it a bit like that. But it's not necessary to always write it like this. You can always convert it into normal number and convert it back when it's needed. Anyway. Then it says, what is the total voltage across each capacitor? All right. For this one, what you guys need to remember, in series, I told you yesterday that the charge on each capacitor is the same. All right. By this, I mean, wait a second. I don't think so that it's very, okay, it's fine. All right. So it means that the charge on this one is going to be 240 microcoulombs, and on this one it will also be the same because the charge stays the same, right? If we have the charge and we have the capacitance, we can obviously find the voltage there. How? Because we know Q is equal to CV, and if that is the case, V will be equal to Q upon C. So the charge was 240 microcoulombs, and the first capacitor that we have is 60 microfarads. So micro and micro will cancel out, so it's going to give us, I think, it's going to give us 8 or 4. I don't know, 4 probably. Yeah. So it's going to give us 4 volts. And then for the next one, we can do the same thing. 240 is the charge remains the same, but the capacitance was 30, which means it's going to be 8.0 volts. Is it clear, everyone?
Yes,
Yeah.
sir.
So this is the capacitance one, this is the capacitance. So it's very, like, if you follow this method, you guys already know that you just need to find the total charge using total capacitance, total voltage. And once you have that charge, it means each capacitance will have the same charge in series. This is all you need to know. Anyway, the last one is the energy stored in each capacitor. Now we already know that the capacitors have this voltage available to them, right? So what we can do is we can use E equals to half CV squared, or any other formula, it doesn't matter. The first capacitance was 60 microfarad and the voltage across it was 4 volts. So we're going to square it because it's half CV square. So we're going to end up with 480 microjoules, like that. And then for the next one, same, half CV square, so it's going to be half. The next was 30 microfarad multiplied by 8 whole squared. So this is going to give me probably 960. So that would be the energy stored in each capacitor. Now, if you ever want to check whether your answers are correct or not, oh my god, wait a second, that's not fair. It's not fair. Wait a second. So if I want to check if this is like the same, it should be the same answer as this one because total energy cannot be changed, right? So you can just add them. Like you can do 480 plus 960 to check if you have calculated correct. So it's 1440. This is just to check if this answer is correct. Do you guys get it? Yes, just like this. So please have a look at it, absorb this, and let me know if you have any questions before I go to the next. All right, people. Now going to the next, okay? In the next part, we're gonna just increase the difficulty just a bit. So let's do that. Question 2. In this one, you have two capacitors in series, like this, like that, and this, and this, that. And then these two are parallel with another capacitor right here, like this. And then battery, like that. Okay, so this is going to be, let's say 12 volts. This is C1. It has a capacitance of 120 microfarad. This is C2. This has a capacitance of 60 microfarad. This is C3, which is of 20 microfarad as well. Okay. So this is the question. Rest of the things are the same. So wait a second. Let me make it a bit simpler in that case. And copy this. Okay, wait, let me put it here and I'll erase the other stuff. Don't need that. Okay, so we're basically following the same pattern to find each and everything, whatever they require in any question. So let's erase all of this and this as well. Okay, fair enough. Now, in this question, the first thing that you see is this is a kind of a circuit which is overall a parallel circuit, but it has a series component as well. So what I'm going to do is whenever you have these kind of circuits, you always need to first basically solve the inner circuit. So I'm just going to write it here. Tip. Solve the inner circuit first. All right, which is in this case this one, by the way. So Now, the next thing you guys should understand is because it's parallel. So I told you yesterday that when capacitors are in parallel, the voltage across each branch is the same, which means that actually this whole thing will have 12 volts across it, and also this whole thing will have 12 volts across it as well. So because each branch will get the same amount of voltage. Okay. So now to solve the first inner circuit, because we want to find the total capacitance, we know that this is like in series. So I'm going to write, let's find what is the capacitance in series. So I'm going to write capacitance in series equals to 1 upon 120 microfarad plus 1 upon 60 microfarad. Now just take out your calculator, write down 1 divided by 120 plus 1 divided by 60, and then take the reciprocal of the answer. So it's going to give you 40. So it means in series, the capacitance was 40 microfarad, which means all of these together have a net capacitance of this one. All right, so just write it down here. Then, if you notice, this 40 capacitance is in parallel with this one. So we already know then parallel capacitance is added. So I'm going to write with a different color. So in parallel, we can say that the total capacitance will be the first capacitance and the second. So in the first part, the capacitance was 40 and the other capacitance is 20. So I'm just going to add it. So it's going to give me total of 60 microfarad of capacitance. Please have a look at it. Let me know if you have any questions here.
No.
Okay. So then they will ask you what is the total charge. Now this is very simple because to find the total charge you only need to use Q is equal to CV. We have the total capacitance which we just found it here, so it's going to be 60 microfarad. We also have the total voltage which is 12, so you can multiply this, and 12 into 60 is probably 720 microcoulombs, like that. Okay, anyway, then what is the total energy stored? Again, it's very simple. You can use any formula, but I like to use this because I don't have to square. Then if I use half CV square, that's fine. If you use that as well, it's not a big deal because I'll show you how you can use two of them. So the total charge was 720 microcoulombs and the total voltage was 12. So you should be getting somewhat around 4320 microjoules. Now, alternatively, if you want to, you can also use half CV square. So you know the total capacitance was 60 microfarad and the total voltage was 12 square. So you will end up with the same answer. It doesn't really matter which formula you're going to use. All right, as long as it is the right one. That's way. All right, is it clear, everyone?
Yes, sir.
Good. Now they say, what is the total voltage across each capacitor? Now this is a tricky one because if you look at the diagram itself, you see that 20 is parallel with 120 and 60. So C3 is going to get the full voltage because in parallel the voltage is the same. So for C3, we are going to write that it basically gets a voltage of 12.0 volts. It's not a big deal. But for the other ones, we have to use the formula again because you know that Q is equal to CV, so V will be equal to Q upon C. So for the voltage of C1, I'm going to use basically V equals to Q upon C. The charge on this one um, is basically we got to find that actually we don't have the charge on the both of these because this total charge this total charge is basically given to all of them, so we don't know that, right? So let's do that. So if we want to find the charge, the capacitance, total capacitance in series was 40, as you can see here. So we're going to add 40 here, and the voltage across was 12. So the total capacitance, the total charge across both of them, for both of them would be this. So now we have to use this charge, not this charge. So remember this, this is the trick that you might fall into. So now for 80 microcoulomb, the first capacitance was 120 microfarads. So it should give you about 4.0 volts. In the next, which is C2, then voltage is charge over this. You have the same charge because they're in series, and the capacitance was, I think, 60. So 60 would mean that it's going to be 8.0 volts. Do you guys get it? Please have a look and let me know if you have a question here. Yes, Abdul Rahman, Abia, Abu Bakr, everything is clear. And Amna, Aisha.
Sir, why
Done.
didn't we use to charge 720?
Why did we use charge 720? That's correct. Because 720 means that there will be charge on this and there will be a charge on these. So the 720 is the charge Q1 plus the charge on the series Q2. It's not the total charge on the series. Do you get it?
Yes.
Because I told you parallel, in parallel circuits, charge is basically different at each capacitor. Like in every branch has a different charge. So we got to find what would be the total charge when it is in series at this branch, right? Then we can basically proceed. Understood?
Yes, sir. Thank you.
Now it says in the last part, we got to find the energy stored in each capacitor. That's pretty simple because all you need to do, we have the voltages, we have the capacitances. We can simply use energy equals to half CV square. So for the first capacitor, I can write half times 120 microfarad, and 120 had this voltage, so 4.0 whole square. This should give you something like 960 microjoules. Then energy 2 will be half CV square. So half into the next one was 60 microfarad. 60 had this voltage, which is 8.0 whole square. When you multiply this should give you 1920 microjoules, like that. And the final one, which is the 21, so it's going to be half times 20 microfarad, and 20 has a total voltage of 12, so 12.0 whole square. So this is going to give you 1440 microjoules. Now to check the answer that we have done everything correct is if I add all of these together, then I should be getting this answer. All right, so let's check if our answers are correct. So 960 plus 1920 plus 1440 basically gives us the same answer as 4320 microjoules, which is right here as well. Understood?
Yes.
Now, please again look at the question carefully. Try to absorb everything with this a lot of information, and I don't want you guys to fall prey to any of these type of questions. Okay, give me like 2 minutes. I'll be back before we do the last type of question. Hmm. All right, I'm back. So now let's go forward. So now let's start with the next type of question. Let's see what we going to do in that one. So in this type of question, let's try question 3. So these type of questions are typical paper questions connected to a battery like that. And this capacitance is called A with 60.0 microfarad value. In the first part, they say, so this is A1, they say calculate the total charge stored by A. Then, in the next one, they say calculate the energy stored. Assalamu alaikum. Deep sir. Please give me the sum is 2 minutes. I'll call you back. Thank you. And part 3 would be calculate the work done by the battery in charging the capacitor. Can you guys please, now this is what I've already done. So can you guys please do this and tell me the answer? You have 2 minutes for this, and then I'm gonna write the next part, which is the real part actually. Hurry up, please. Where's the meat? I don't know. That's not fair. Wait a second. Okay.
Sir, aren't we supposed to have the value for voltage as well?
Sir,
Yes, yes, what you were saying?
voltage. Where's the voltage?
All right, all right. Oh, yeah, okay. Okay. I'm sorry about that. This is basically 10 volts. I didn't write it. Can you please do it now? I'm so sorry. answer for the first one? Who got it?
600.
600. That's correct. Very good. Thank you, Samir, for sending your work. So this is 60 microfarad times 10, so 600. Okay, so the next one,
3000.
3000. You are wonderful. That's correct. That's half times 60 microfarad times 10.0 whole square. So that's going to be 3000 microjoules. Okay, that's good. And what about the last one? Who got this? No, no,
Say
no.
answer same.
Sir,
No.
answer 3000.
No, galat. That's not correct.
As in
Basically, you guys
6,000.
need to 6,000 is the correct answer. Very good, Aisha. Because I told you that work done when you're doing with respect to battery is voltage times the charge only, which means voltage is 10, the charge is 600 microcoulombs. So the total work by the battery would be 6,000 microjoules. Do you guys get it? Now, the point to remember that you guys forgot, only Aisha remembered, is if you go back to the notes, I wrote here that basically the work done by the battery is V times Q, like here, as you can see. But the energy stored is half V times Q. This is why I said that basically only 50% of the energy is stored in the capacitor. So if you had remembered that, you would just multiply 3000 by 2, it would give you 6000. Is it clear? So now do not forget that only 50% of work done is stored in the capacitor. Is it clear? Will you guys forget now?
So yes, sir.
Good. Now, the next part that we're gonna do, oh my god, that's not fair. Wait a second, please. I missed. Basically, I click the power button. Wait. Okay, so I gotta share the screen again. Now, if you do the next part, I will be very, very happy. So the fourth part, which is, sorry, the part B on this one is, it says the capacitor A is now disconnected from the battery. All right. And is placed parallel with an uncharged capacitor B of value 40 microfarads. Now it says find the charge in A and in B. They've also given you the diagram. Like that. This is the 60 microfarad A, which is fully charged right now. B is uncharged, which is 40 microfarad. And now they want you to find the charge on each of these. Can you please do that? Let's see. Now, this is the real question, you know. And once you've done that, then in part 2, we will also be finding, need to calculate the total energy stored by this combination. Okay, part 1 first. The trick to this question is, I'm just going to give you a tip that when in the previous part it was charged by the battery, the total charge on A was 600. So this is the trick. But now we need to find what is the charge on both of them when they're connected in parallel. All right, you people, you got an answer? Remember the first step. Remember the first step. The first step should always be that you got to find the total capacitance in this. This should be always your first step. So now the total capacitance in, because they're parallel, so we just got to add them together like this. So that would give us a total capacitance of 100 microfarads, which means they share this. Now, I'm going to teach you one conventional method and an alternate one. So let's have a look at the conventional first. So method 1. When you got this, you guys need to understand this A had a total charge of 600 microfarads. Now this charge, because charge gets split when it is in parallel, so some charge will remain on this, some of this whole charge will go into the other one. This is what we need to understand. So now I'm going to use Q equals to CV to determine what will be the voltage across these two, because voltage will be the same, right? So the total charge that there is available is 600 microcoulombs. The total capacitance is 100 microfarads, and we can find the voltage. And then when you do that, it's going to be 600 divided by 100, so it's going to be 6 volts, which means this one will get 6 volts, and this one will also gets, this also gets 6 volts. Let me write it here because I need space at the bottom, right here. Then what you're going to do is, if you want to find the charge on A, what you do is you multiply 60 microfarads, because Q is equal to CV, right? So I'm writing 60 microfarad. It has 6 volts of charge, voltage. So it's going to be 360 microcoulombs, like that, right? Finally, the charge on B is going to CV again. That is 40 microfarads multiplied by 6. That's going to give us 240 microcoulombs. Do you guys get it? Any questions here? Please let me know. All right. The next then. So this is one of the conventional methods. And the other method, I'm going to basically use a different color for that so you guys can see. So this is a very unconventional one, but this gives you answers quicker. So for charge A, once you've done this, remember there's a way. The way is you're going to basically find the charge on this one. So you're going to put it on the top and then divide it by the total capacitance that is there, which is 100, and multiply it with the total charge that you have available. So this way, you will get 360 microcoulomb just directly. And for QB, you have 40 microfarads as the capacitance divided by the total capacitance multiplied by the total charge available, and this will give you 240 microcoulombs. So whatever method you like, you can basically use it. Is that clear, everyone?
Yes.
Yes, sir. सर लेकिन इसको क्या हम हर टाइम यूज कर सकते हैं या इसका कोई सिर्फ इसी तरह का क्वेश्चन पड़ेगा?
Come again, please.
सर इस तरह की वर्किंग है, ये हम हर तरह के क्वेश्चंस पे कर सकते हैं?
Yes, all questions, like you see, every question is the same. The first thing you always need to look for is the total capacitance. Once you have that, you can use Q is equal to CV and you can find any answer that you want to. It's not a big deal. Is it clear?
Yes, sir.
For method 2, you can do any question with this as well. Just remember, you need to have total charge, you need to have total capacitance. So whatever capacitance you're looking at, divide that with the total capacitance and multiply that with total charge. You're going to get the charge on that capacitance in parallel. It's very simple. Is it clear? Perfect. Now this one, I'm going to give you this as a homework. So when you meet again on Monday, we're gonna continue from this. This chapter is a bit longer. We just need to, I think I still need at least 1 or 2 classes to finish it. All right. So I will see you then. Have a great weekend. Bye.
Thank you, sir.
Allah Hafiz.
Thank you, sir. Bye.